Hello everyone. Today I am presenting my Tech Talk presentation. I am Karthik from AAA department. The subject is mathematics. The topic is diagonalization of a complex matrix. Let me see the introduction. Introduction. A square matrix A is called diagonalizable or non-defective if it is similar to a diagonal matrix. That is, if there exists an invertible matrix P and a diagonal matrix D such that P minus 1 into A into P equal to D, or equivalently A equal to P into D into P minus 1. The algorithm of the diagonalization. Find the distant eigenvalues of A. Find n linearly independent eigenvectors v1, v2, so on up to vn corresponding to the eigenvalues of A. From the matrix P with Vi as columns L equal to 1, 2, 3, so on up to n. If P is orthogonal, then P into T into A into P equal to P minus 1 into A into P is required diagonal matrix. The diagonal matrix entries begin the eigenvalues that are x1, x2, x3, so on up to xn corresponding to the eigenvectors v1, v2, v3, so on up to vn respectively. Next slide. A linear map T is to V. V is diagonalizable if and only if the sum of the dimensions of its eigenspaces is equal to dim of V, which in the case if and only if there exists a basis of V consisting of eigenvectors of T with respect to such a basis T will be represented by a diagonal matrix R given by the eigenvalues of T. The fundamental fact about diagonalizable maps and matrices is expressed by the following ways. A matrix n into n, matrix A, is over a field phi F, field F is diagonalizable if and only if the sum of the dimensions of its eigenspaces is equal to n, which is the case if and only if there exists a basis of f n into n consisting of eigenvectors matrix A. If such a basis being found, one can perform the matrix P having these basics vectors as columns and P minus 1 into A into P will be diagonal matrix whose diagonal entries are eigenvalues of A matrix A. The matrix P is known as a model matrix of A. Next slide. And matrix is diagonalizable over the field if it has distinct eigenvalues in, that is, if its characteristic polynomial has distinct roots in, that is, however, the converse may be false. Consider the matrix -1, 3, -1, -3, 5, -1, -3, 3, 1, which has eigenvalues. The above matrix, if we solve this matrix, we can get the eigenvalues like 1, 2, 2, where not all the distinct and is diagonalizable with diagonal form similar to 1, 0, 0, 0, 2, 0, 0, 0, 2. And change of basis matrix P, that is 1, 1, 1, -1, 1, 1, 0, 1, 0, 3. The converse fails when A has eigenspace of dimension higher than 1. In this example, the eigenspace of A associated with the eigenvalue 2 has a dimension of 2. Conclusion. At last, the conclusion. Diagonalization of complex matrix is the technique of finding diagonalization of a matrix. Matrix is the process which is very important topic in all engineering fields, and diagonalization play a key role in it. The diagonalization plays a major role in the process of matrix, the matrix process. It is very important topic, matrices. This I want to conclude at last at the ending of the diagonalization of a complex matrix. Thank you everyone. Thank you for listening.